Dana, here is the video I promised you on the problems you sent me. I'm actually going to have to make two videos because it would have been too long to try and put it all in one. Just comments on number 9. I know you know what you're doing there, but I would show a little more work there. In other words, it looked like you erased some of your work, maybe because you didn't have enough room there. But she will want to see the work there. You got the right answer. Number 12. Well, actually, let's start with 11. So 11 and 12, you're doing a little more than you need to do there. So, but I think you have the right idea. For number 11, you want to write a line that's parallel to the given line and passes through the given point. So solve that equation for y. I think that's what you did so that you can see the slope of the line is -1/2. Your line's parallel, so your slope's also going to be -1/2. And then you have an x value of 1 and a y value of -6. So you can just plug that into point slope form. You can see I've done that in blue. And then if you need to solve it for y, you can see the final answer there. So you're not getting quite the right answer there. You must have an error. I think when you distributed, you said -1/2 times -1 was +2. But it's not, it's actually +1/2. So this number right here, that should have been a plus, that should be 1/2 right there. And then if you add 6 over, sorry, you subtract 6, 6 take away 1/2 would be 5.5. I wrote that as 11/2. So hopefully you understand what you did there. And then number 12, you also have an error, and you're making more work than you need to do. If you look at my work, all you have to do for these problems is find the correct slope that you're going to use, and then you can plug it into point slope and then solve for y if she asks you to. Make sure you know, because you may not even need to solve it for y. She may take it in point slope form. So this form right here might be fine for her. I would ask her that when you're testing. I think she'll answer you. So the slope there, you typoed. When you went to plug in, you can see you plugged the 11 in correctly, but that other number with the 11 should have been a -2. And since it's a minus sign, that flips it to a +2. And so I think you can see my work there and you can correct your error. But overall, good job. Dana, here's 17. 18 is going to be on the next slide. 17, you have 3 variables and 3 unknowns, or 3 unknowns, 3 equations there. But you'll notice in 17, the top equation only has x and z. It doesn't have a y. In 18, that won't be the case. So I just wanted you to see visually, that's why I have 17 and 18 on this same slide, so that you could see visually the difference between the two scenarios. 17 is a little bit easier because that top equation doesn't have y in it. What you're going to want to do is take the 2 equations that do have y and eliminate one of them. And I think you're pretty comfortable with elimination. I notice that if I look at the middle equation, it has a -1y, and the bottom equation has a +3y. So I'm just going to multiply that middle equation by 3. So I get 6x minus 3y minus 18z equals 12, and then I can add, and the y's drop out. And again, I chose to get rid of the y's because I already have an equation that doesn't have y in it. And now it's just a 2-variable system with 2 equations. And so I took the equation at the top, the original, that x minus 4z equals 1, and I multiplied it by -5 because I want to get rid of the z's. That seemed easier to me than multiplying by -8 to get rid of the x's. So once I do that, I think you can see my work there. I don't think there's any big mystery or need for explanation there. I add and I get rid of the z's, and so now I have 3x equals 15, and I know x is 5. Then I can take that x equals 5, and I can just plug it in to the equation, that top equation now. So you can see if I do that, I get 5 minus 4z equals 1, and then I can solve for z, and I now know z is 1. So I know that x is 5, z is 1, and now I have to choose one of the 2 equations that has all 3 variables in it and plug in my x and my z values. And when I do that, I get y equals 0. So that's number 17. I think you can follow my work there. If you have questions, email me on that. Let's take a look at 18. So if we look at 18, you'll notice that all three equations have all three variables. So basically, when you're in this situation, if you look to the right, I've written down the steps. You're going to eliminate 3 times. The first 2 times, you're going to eliminate the same variable just from 2 different equations. Then you'll have 2 equations that have just 2 variables, and it becomes like the problems you've been doing in my class, and you have to eliminate 1 more time. And then you have to go back and substitute what you found in twice, because after that third elimination, you'll know one of the variables. You'll plug it back into one of the 2 variable equations. You'll get an answer, and then you'll take those 2 numbers and plug it into a 3 variable equation to get the third one. Now the issue, I can't walk you all the way through it, is because this problem, what happens, if you look at my work, is that the variable drops out in step 3. So what I did was I chose to eliminate y twice, because one of the equations, or one of the variables, has to be eliminated twice. And I chose y because the middle equation has a plus y, and then the top one is -2 and the bottom one's -3. So what I can do there is just multiply that middle equation by 2, and that'll eliminate y once. Then I can go back and do it again using the middle equation again, but now I'm going to multiply by 3 so that I can use the bottom equation. You're always going to use one of the equations twice, and then you have to use it once with each of the other 2. And so you can see I got rid of y twice. Now I can take those 2 equations that only have x and z in them and eliminate either x or z. The problem with this, it's not really a problem, it makes the problem shorter. But what happens there is when I go to eliminate x or z, they both drop out. And so then I have to look at what kind of a statement am I left with. I'm left with a false statement in this case, which means there's no solution. Had I been left with a true statement, then it would have been an infinite number of solutions. Now, just to be clear, let's say it hadn't dropped out, and let's say I had gotten an answer like, let's just say I got x equals 2. Let's keep this simple. Let's say I had gotten x equals 2. I would take that x equals 2 and I would plug it back in to any of my equations that only have x and z in them. So like I might plug it in, let's just say right there, and I would solve for z. Then once I know x and z, let's say I solve for z and I get 3. Now I would take both of these and I have to go back to one of the original equations that has all 3 variables, plug x and z in, and find y. And again, which variable you eliminate to get started is entirely up to you. I chose y because the middle one had a +1y, and it was easy to just multiply that middle equation by 2 and use the top equation, and then by 3 and use the bottom equation. I think you're good enough at this that you're going to be okay. But if you have questions, let me know. I'm going to make you another video for the last question that you needed help on.